Hello everyone. In this video, I'll demonstrate how OpenCV is deployed into Qt Creator to track objects in real time. OpenCV is an image and video processing library with bindings in C, C++, Python, and Java. It is used for all sorts of image and video analysis, like facial recognition, detection, license plate reading, photo editing, and a lot more. Although OpenCV comes with its own GUI library, it has no support for buttons and some other components. So I've resolved to using Qt Creator. It should help us fix those shortcomings. So if you see here, we have our Qt project file open. OpenCV is already installed and set up. If you wish to learn how to install and set up OpenCV and make it compatible with Qt, there's an excellent step-by-step description on Zahid Hassan's WordPress page. I have placed a link to that in the description below. Before I proceed, just so you know, this is not a step-by-step tutorial for this program. It's rather just a demonstration after I've written all the code. If you do wish to see the source code, I have placed a link to that also in the description below. Yeah, so now let's proceed. Let me run the code. If you notice over here, Qt has outputted an error message that says Windows 10, well, the version of Windows 10 we're using is untested. That's because the version of Qt that I'm using was released before the Windows 10 release. So just ignore the message. Some of you might not even have it if you have a newer version of Qt Creator. Well, let's have a look now. Here's the original image that's in the RGB color space, or as OpenCV calls it, the BGR color space, which is nothing but the blue, green, and red channels. That image, once it's converted to HSV, we should be able to see all the contours surrounding different objects. The contours helps us isolate the object that we're interested in. Contours are basically nothing but the outline of the object. Once we have that, we isolate the object here in the threshold image. So the idea basically is each frame of the video is converted from its BGR color space to the HSV range, and then we threshold the image with the range of colors of the object. This allows us to extract the object alone. By thresholding, I mean we isolate the object in this space over here. It might sound a little confusing right now. Let me just show it with an example. Let me bring in the first object that we're going to be working with. It's just a toy block. It's green color. So what we do is we play around with these HSV values over here until we have the image that we're interested in isolated over here in white. Once you move them, if you see, things are changing over here, and the object that we're interested in is over here. Bright objects usually always fall in the higher range of the spectrum, so for all three of them, for H, S, and V, it always falls in the higher range. I've done this a few times before, so I'm just gonna go to the places I think it should be at, but for yourself, there's just play around until you get the result that you want. Okay, so about this much. This, I should reduce it. There you go. See, a lot of it is disappearing, and we have the object that we are interested in just by itself now. Let's increase the saturation. Saturation has a high effect on the color green, so you see it's just very effective once I increase that. And let me narrow down the range. Okay, getting a better hold of it now. And the B. You can skip these things. Well, now it's already done, but for the next object that I'll be showing, you can skip them until I have finished it. Well, okay. So if you see here, the object is being tracked now, and we can even see the coordinates that that keep changing as I move it to different places in the frame. You can see that in the code below, just to show all the coordinates on here. At the moment, it's giving the tag default because that's just the tag for the varying HSV value. But if you want to give it a tag of your choice, you can just write a name over here. I'm going to call it green block. It's a generic name, but it just does the work for now. All right, let's go back to the default settings and back to the full threshold. And let me bring the green block into the picture. There you go. If you see here, it's giving us the name and the coordinates of the green block, and it's locked on pretty well. It's very responsive and it's moving very smoothly. Even if I do it really fast, it just keeps tracking it. That's the beauty of OpenCV. It's just very effective like this. Alright, so that's just one object. What if I want a second object in this now? Okay, let me bring in the second object that I want to track. This one is red in color, so let me just move the HSV until I have this object tracked. Alright, no, I guess I can leave the S max. Increase the V a little bit. And like I said, for bright objects, it's usually at the higher range. There's always some noise over here. Well, this is a little too much noise. Let me just fix that. There we go, I think. Alright, so although there is noise sometimes, in the code I have written in such a way that usually the larger threshold image will be tracked and the smaller ones are neglected, so the noise is usually neglected, which is filtered out. Alright, so let's give it a name. I'm going to call it a red block. Once again, very generic, but it should do the work. Alright, let's bring that back into the picture. There you go, the red block is being tracked. Once again, very responsive and with the coordinates shown below. And let me bring back the green block. There you go. So both the red block and the green block are being tracked. It's working really well and really smoothly. Well, that's all that this tutorial is supposed to show. If you have any questions regarding this project, you can just ask it in the comment section below, and I'll answer it as soon as I get to it. I hope to post even more OpenCV based projects into this YouTube page, so just subscribe and just stay in touch. Thank you.